I just want to speak a little terminology here. We have two things that are very similar and confuse students quite often, even though they're pretty easy. One is called the average rate of change. One is called the instantaneous rate of change. It's this simple. Rate of change is just another way of saying slope. We just don't use the word slope that often anymore. Now that we're in advanced stuff, we talk about rates of changes. Why? Well, because slope is a change in y over the change in x. We're looking at the rate of change of two different variables and comparing them. We're seeing how steep a graph is, yes, but we're looking at how money is changing over time, how distances are changing over time, lots of things change over time. Okay? The average rate, when you want to average something out, you're looking at finding the slope between 2 points, and this is really easy to figure out. I think you've been doing it for quite a while. Oh my gosh, yes, it's called the slope formula, although there is a light that's right on top of that. Sorry, that's a little rough. The instantaneous rate of change is the slope at one point. We have a much easier way of putting this. I'm going to put it up a little higher so it's not in the light beam, but that's the derivative. The derivative tells you the slope at exactly 1 point, the slope of the tangent line. Okay? So that's what these two are. And now let's take a look at an example. So I rewrote this up here so you can see it a little better, and I actually wrote it two ways with the y values or f of x function notation, which still represents the y values. I also want to point out that even though this is not an official abbreviation, I don't know if any other teachers or professors in the world use these abbreviations. I rather like them because I'm lazy. But AROC is just my shorthand way of saying the average rate of change, and IROC is the instantaneous. Here's your example. We've got something, g, maybe it stands for gravity, I don't know. G of t is equal to this function. Maybe t is time, I don't know. Anyhow, I want you to find the average rate of change from 0 to 2. Here's the first step that you need to complete. First, find the points. How are you going to get the slope between 2 points if you don't have the points? And since my interval goes from and including the point 0 to 2, I'm going to choose the points 0 and 2. Thank you very much. Now, find the slope. Apparently, that average rate of change would be negative 32. Every second, it seems to go down about 32 feet. Is that a reference to physics? No, couldn't be. Instantaneous. Okay, so this one I actually prefer quite a bit as long as the function's easy. This one is. Instantaneous, take the derivative. That's what instantaneous rate of change means. Then once you have the derivative, actually plug in the number 0, and then plug in the number 2. So it seems that my instantaneous velocity right at 0 time is 0. And then it's negative 64 after 2 seconds. But somehow that averages out to be negative 32. That kind of makes sense. Now that's wonderful for a quadratic. If you have other types of functions, this average rate of change may not be the average of these two numbers. And that's simply because speeds of something can go up and down. They could change quite a bit. This velocity is linear and it stays in that manner the whole time. This is just average rate, instantaneous rate. Very simple definitions. One means slope between 2 points. One means the derivative or slope at 1 point.